All right. Today is an exciting day. Today is the day we drop the pre and we just do some calculus. We're going to talk about limits a little bit. So if you watched the video yesterday, you probably have a good idea of what it is. So I'll give you my own version of what a limit is. So we're going to take a look at a function x minus 4 divided by x minus 4. And the best way for us right now to look at a limit or to think about it is on your calculator. So we're going to, in parentheses, go x minus 4. And divide by itself, so you're just graphing really y equals 1 right now. And we hit graph and we take a look, and all you have is a completely straight line. So as you go down this line, the x value is going to change throughout. The y value is always 1. So if x equals 0, y is going to be 1. Well, let's give it a try. We have trace, and let's press 0. And when you do that, plug in 0, get 1, and your calculator tells you so. How about if we plug in a 1? What do you get? So we'll go trace and hit 1. Hey, you also get 1. So we say this function is defined at both of those. Defined just means when you plug in an x, you get out a y. How about when you get to 4? Well, 1, 2, it looks like there's a value there. I mean, there's a straight line, but let's plug in 4 and see what you get. And if you look at your calculator, there's not a value there. It is undefined. So in other words, you can't do that math. Okay? You can't plug in 4. 4 minus 4 is 0, but on the bottom you can't divide by 0. So what we do in math is we take what's called a limit. Okay, so a limit is when you approach something. So if you notice, first of all, what is a limit? A limit is a y value. Okay, a limit is a y value. So what you're going to do is you're going to approach an x value from one side. So we'll just start with the right. Approach from the right. And we're going to call that the positive side because that's where all the positive numbers are. And then you're going to approach from the left. We're going to call that the negative side. We'll use that notation in a little bit. And we're going to compare those numbers. These numbers have to be equal. And if they're equal, then we're going to say it has a limit at that value. So right here, if I plug in 4, is there a value there? There's not. But if I take a limit, the limit is going to be 1. Because if I go on my calculator and I approach it from the right, I approach the x value of 4 from the right, you get 1 for a y value. And if you approach it from the left, you get the exact same value. If you get the exact same value twice, you got yourself a limit. All right, let's take a look. So here's the notation. LIM means find the limit as x approaches 2. So for right now, we're going to stick to our graph and our table. So I'm going to go to y equals, and I'm going to go to 3x minus 2. I'm going to graph it. And, and let's just approach 2 from each side. I'm going to hit trace, and let's have our x values approach 2. It's going to get closer and closer and closer. So we're approaching here, getting closer to 2, and it looks like I'm getting closer to 3.9 or maybe even 4. So what I just did is I just approached from the left side and got a value of 4. Now let's approach from the right side. So approach from the right side means I'm going to come at it from this side until my x value is basically 2. And it looks like from this side it's also approaching 4. Now the problem with your calculator obviously is it says 4.4. How do you know that's 4 and not 4.1 or something like that? So we approach from the left, got 4. We approach from the right, got 4. Because those two numbers are the same, our answer is going to be 4. Okay. A great way to do this is to look at your table. Hit second in table. If you want to have this table set, will help us as well. Table set. We're going to start at 0. And we're going to go, let's set it by, actually, let's not start at 0. Let's start at 2. We'll start at 2, and let's set the table. This delta means how much do you want to increase? Let's set it like 0.01, like 100th. Now we'll hit second and graph and go back to the table. And if you look at this, this is a great way to take a limit. Because if you look at our x values are approaching 2, and we're getting y values. Here we're approaching 2 from the other side. So these numbers are approaching 4 from the top. These numbers are approaching 4 from the bottom. And because they're approaching the same number, we have a limit. Also, if you look for this, guys, this graph is what we call continuous graphs. This one is continuous. So you might, this whole time, been saying to yourself, why don't you just plug in the number 2? And you can. This is what we call direct substitution. Direct substitution means plug it in. 3 times 2 minus 2 is going to be equal to 4, so you've got your limit. This works for anything linear, anything quadratic, or even more specifically, anything that's a polynomial. What all these graphs have in common is that they're continuous. Graphs that have no breaks in them, no holes. But what you really have to be careful about, beware of square roots. Anytime you have a square root, there's going to be numbers you can't plug. There's going to be negative numbers. Beware of dividing by a variable. Divide by x. Because anytime you have x in the denominator, like this one up here, x here is in the denominator, there's going to be numbers that you can't plug. All right, so let's just try taking a limit, and for today, we're just going to use our calculator. We're going to graph, and we're going to use the table. We're not going to get into too much of the substitution. Well, first let's try it. Can you plug in 0? Seems fine here, but when you do 0 down here, 0 plus 1 is 1, square root 1 is 1, 1 minus 1 is 0, can't divide by 0. So let's go on our calculator. It's really important that we get everything parenthesed properly. So we're going to go all together, the square root of x plus 1, boom, minus 1. Make sure that minus 1 is outside the square root. And let's just try a graph. All right, so here's what it looks like. Here's how you take a limit. As I approach 0, let's approach it from the bottom. It looks like my y value is getting close to 2. Now let's approach it from the right. It looks like my y value is approaching 2. So because I'm approaching 2 from the left and approaching 2 from the right, we're going to say that the limit is 2. Let's double check on our calculator. We'll go to the table. We'll get close to 0. I'm going to use table set here. Table set, let's start at 0. And let's look at this one right here. So right at 0, you can't get a value, but it looks like these y values, we're getting closer and closer to 2. We're getting closer and closer to 2. So because those two values are the same, it has a limit. Let's try another one. How about, if you want, you can pause it and try it on your own, or just try it with me as well. Okay, I'm going to make sure everything in the numerator goes together. X cubed minus x squared plus x minus 1 divided by together x minus 1. So put that all in there. We're going to graph it. And calculator's got to think about it. Okay, so let's take a look. As we're approaching 1, it looks like we're approaching 2. So I'm going to approach it from the left and get, 2. Approach it from the right, looks like 2. So before we just slap down 2, let's take a look at the table. And table set, let's approach 2 and see what happens. And so, oh, I'm sorry, approach 1 is what I was going to put, my fault. Approach 1, and let's approach 1. It looks like my y values are getting close to 2. My y values are getting close to 2, so because they're approaching the same number from both sides, we have a limit. Well, maybe it's helpful to look at ones that don't have a limit. The limit does not exist. If you want to watch some Mean Girls, that's fine. You can yell it out. The limit does not exist. All right, so let's take a look at this one right here. If you want the absolute value, you have math. We can go over to num, and you get absolute value. Absolute value of x divided by x, and let's see what we get. Well, I'm going to look at the graph, and as we approach 0, so this limit does not exist. And why? Let's take a limit from the left side. If I approach a limit from the left side, from the left, my y value is getting closer and closer to -1. If I approach it from the right side, this one is getting close. Sorry, I'm writing so messy. -1. If I look at it from the right side, it's approaching 1. Since these numbers are not the same, these are different numbers, we have a DNE. This limit does not exist. If you want to take a look, what does the table look like? So let's hit the table, and we want to approach 0. So I'm going to hit table set, and I'm going to go to 0. And let's take a look. If you look, I'm approaching 0 from one side, I get one set of numbers. I approach 0 from the other, I have a different. So these are different numbers, and they're not getting closer to each other. They're not converging on the same number. So because those numbers are different, it doesn't exist. So that would be under y. All right, let's try this one right here. We'll go 1 divided by x squared. Take a look. We're going to graph it. All right, the next part of the definition is we're going to approach it from the left side, approach 0, and we get infinity. The problem is infinity is not a number. That's an idea. So even though it's approaching the same thing, it has to be an actual number. So this one also is DNE, and the reason is what we say, it's unbounded. Unbounded means it just goes up or down forever and ever with no, it's not approaching the same number at all. All right, the last one, let's take a look at a graph. Let's take the limit. It doesn't have a limit here, but let's take the limit of this as x approaches 2. Okay, limit as x approaches 2. So if we're going here, I'm following it, I'm approaching 2 on the graph. This y value is getting closer and closer to 1. Let's approach it from the right side. This y value is getting closer and closer to -4. These numbers are not the same, so we're going to say DNE. So it's not the fact that there's a break in the graph, it's because these y values that we're getting close to and these are not the same.